objectives in this lesson is to decide whether an ordered pair is a solution of a linear system. A system of linear equations is two or more linear equations whose solutions we're trying to find. In this lesson, we will work with two linear equations. A solution to a system of equation is the ordered pair or pairs that satisfy both equations. In this example, we're asked to determine if 4, 1 is a solution to the system of equation. So the only way we're going to find out whether this ordered pair is a solution is by plugging it into both of the equations. Recall that to be a solution, it must be a solution to both. So we're going to remove the x and replace it with 4 because 4 is in x's place. We're going to remove y and replace it with 1 because 1 is in y's place. Now you have to do one at a time. So let's start with the first equation first, removing x and replace with 4, remove y, replace with 1. Order of operations, 2 times 4 is 8, and 8 take away 1 is 7. So therefore, it does check out for the first equation that the ordered pair 4, 1, it is a solution to the systems of equation. Anytime you plug it in and you wind up with both sides being the same, then that means that that ordered pair is a solution. Now, all we have to do at this point is to plug that ordered pair into the second equation and see if we have that same result of being true that both sides are the same. So into the second equation, remove x and replace with 4, remove y and replace with 1. Let's do order of operations. 4 times 4 is 16. 3 times 1 is 3. 16 plus 3 is 19. It does not equal 27. So here we are left with a false statement because 19 is not the same as 27. So therefore, we can conclude that the ordered pair of 4, 1 is not a solution to the systems of equations. In order for it to have been a solution, both had to be true. In this example, we're asked to determine if 0, 1 is a solution to the systems of equations. And the only way you're going to find out whether it is a solution or not is that you have to plug it into both equations one at a time. If when you plug it in, it leaves you with a true statement, then it is a solution. If when you plug it in, it leaves you with a false statement, then it is not a solution. So let's go ahead and plug it into the first equation. Remove x and replace with 0. Remove y and replace with 1. Let's do the math. -4 times 1 equals -4. And notice that it does leave us with a true statement. -4 is equal to -4. So yes, it is a solution to the first equation. But however, in order for it to be a solution, it must also be a solution to equation number 2 as well. So let's go ahead and plug it into equation number 2. Remove x and replace with 0. Remove y and replace with 1. When we do the math, we can see that that is a true statement. We're left with both sides being 1. 1 is equal to 1. Since both equations yield true statements, we can conclude that the ordered pair of 0, 1 is a solution to the systems of equations. In this example, we're asked to determine if the ordered pair -2, 3 is a solution to the systems of equations. Now, the only way we're going to find out whether it is a solution or not is we have to plug it into the equations one at a time. Let's start with the first one. remove x and replace it with -2, remove y and replace with 3. If when you plug these in and do the math, if both sides are the same, meaning that's a true statement, then that is proof that it is a solution. So let's do order of operations, starting with the multiplication. 2 times 3 is 6. 6 combined with a -2 is going to give me 4, which does equal to the right side. So 4 equals 4. That is a true statement. So that means that the ordered pair of -2, 3, it is a solution to the first equation. Now we have to plug it into the second equation to see if it is a true statement as well, because that's the only way it's going to be a solution, is if it is to both equations. So into the second equation, remove x and replace with -2, remove y and replace with 3. Let's do the math on the right side. We have 3 times -2, which is -6. And -6 combined with a +3 is going to give me a -3, which is not the same as the left side of 3, because 3 is not the same as -3. And since equation number 2 gave me a false statement, we can conclude that the ordered pair of -2, 3 is not a solution to these systems of equations. Remember, to be a solution, it must be a true statement for both equations.